Oh, D, that looks fun. Look, there's no point in putting any of the luns on the dv by dx part. We'll just have to make that 1, and that will integrate to give x. And so we're going to have this as the ln of x all squared. And we can differentiate that. It's just going to be a chain rule, isn't it? So the chain rule, we're going to brackets stay the same, but the power goes down by 1. I'm going to times by the power, and I'm going to times by what this differentiates to give, which is 1 over x. So I'm getting that. So this integral, look, if you're worried about that, you need to go back to the differentiation chain rule work. But what does this give? It gives u times v, which is x times the ln of x all squared, minus the integral of these two things times together. So the x will now cancel as we got that. So we got minus 2 ln x dx. Now, means we need to work on this part as well. So I'm going to do another chain rule here, and not chain rule, another by parts. U equals ln x, and dv by dx this time equaling 2. That one integrating to 1 over x, and that one differentiating to 1 over x, and that one integrating to 2x. And this gives these two things times together. So I've got 2x ln x minus the integral of these two bits times together, which is just 2x. Right, let's be careful with our answer. All these minuses always cause a bit of trouble at the end here. So the first part was x ln of x all squared. Then we're minusing that, so minus the 2x ln x. Then I've got minus minus, which is plus. This integrated gives a 2x and a plus c on the end there. So that's my answer there. Stop there, or I will just go over that again just briefly. So imagine if I wanted to integrate y is ln x all squared using the chain rule. I'd let u equal ln x, and so y would equal u squared. That would differentiate to 1 over x. This would differentiate to 2u. I'd times these two things together, and so I'd get 2 over x times by u, which was ln x. That is what I got up there.